All right, I am going to go ahead and get started here. At any time you guys have any questions, I've muted everyone's phones, but if you have a question, please feel free to type that into the chat box at any time. I'll be monitoring that and trying to answer those questions as soon as they come in and as we go. But we will also have a section or a time at the end of the presentation for any questions that you have as well. All right, so let's go ahead and get started. The 800 series pressure transmitter. So today what we're going to kind of go over, just to give you what the agenda is, we're going to talk about the principles of operations, give you a product overview, some applications, how to order, and then a summary and some questions at the end. So first let's look at the 800 series as a whole, as the family of SOR pressure transmitters as a whole. And so the 805 PT is where we kind of begin. So the 805 PT was the first part or product of the 800 series that was launched back in 2009. So it's crazy to think about 2009 almost being 10 years, or it has been 10 years ago. The 805 PT is just kind of a basic analog pressure transmitter that offers you a 4 to 20 milliamp output as well as a 1 to 5 volt DC output. Now, a couple of years later, we launched the 805QS. The 805QS is basically everything that the 805 PT is, except it includes a switch output. So it's a pressure transmitter and a switch all built into the same unit. And then a couple of years later after that, we launched the 815 PT and the 815 DT. The 815 PT and the 815 DT are what we call smart pressure transmitters. So they offer a lot more features. They're smart, which means they're able to be communicated with. They have a microprocessor in the electronics that allows you to communicate it via HART or Modbus or some other communication protocols. And also it gives you some other features and benefits as well that we'll get into later. Then there's the 815LT, which is the most recent of the products that we've launched. So we've actually launched that just here in the past couple of months. So very new for the 815LT. The 815LT is the exact same product as the 815 PT, except it is a submersible level transmitter. So it has the capability of being submerged in a liquid to monitor the head pressure to give you a level output. So first we'll get into the principles of operations of these products. So this is a basic cutaway view of the transmitter. Now the 805 and the 815, the electronics themselves are slightly different. That's really the difference between the two. The housing, the process connection, the sensor itself is actually the same as well. The main difference is actually the electronics and what goes onto that circuit board. That board for the 815 has some different components, such as components on there that gives it all the features such as HART and Modbus and communication protocols and other things like that. The actual pressure sensor itself operates on a Wheatstone bridge design. And so what a Wheatstone bridge is it's a series of resistors that are printed essentially on the backside of a flexible diaphragm. And so that diaphragm, as it senses the process pressure and it flexes, as the pressure increases, it will cause that diaphragm to flex. And as that flexes, you have these two variable resistors, R1 and R4 here. Those variable resistors, as the pressure changes and the diaphragm flexes, the resistance in those resistors will change as well. And that's actually what you're measuring, is the change in resistance on those resistance, ultimately changing the voltage of the circuit. And so we then amplify that signal and convert it into a more usable signal for operators, such as the 4 to 20 milliamp signal. That's one of the most commonly used methods for obtaining a pressure measurement out there in the field. For our 815LT, our submersible level transmitter, the way it works is you have the same pressure sensor in there, except that pressure sensor is measuring the hydrostatic pressure all around it. And so it's kind of like when you go into your swimming pool, or have you ever gone in a swimming pool and try to go down at the bottom of the swimming pool, the pressure is a lot higher when you're down the deeper you go, and you can feel the pressure in your ears. Well, that's what we're doing here, is we're just measuring how much pressure is down in the depth of the tank or the vessel or the well or whatever you're trying to measure. And so that pressure is, you can only measure the level at the zero level at where that sensor is at. And then anything above that, you can measure the hydrostatic pressure, the amount of basically weight of liquid that is on top of the pressure sensor. And so for instance, if you had 10 feet of water on top of this sensor, you would have 10 feet of water column of pressure on the sensor. Now, this submersible level transmitter only really works for vented tanks or vessels that are open to atmosphere. The reason for that is you need to have reference to the pressure on top of you need to have reference to the pressure on top of the liquid. That pressure is then pushing down on top of the liquid as well, and that can fluctuate the level measurement output. So what you're taking reference to is the gauge pressure or the atmospheric pressure out there on the outside of the tank. And the way we do that is we have a vent tube that goes all the way from the sensor here up the cable and then out into the atmosphere. And you can see here's a picture of our cable. You can see all the wires coming out of it, as well as the actual vent tube here in the middle. These little blue strings here are just basically filler to give the cable some strength and structure. But this tube is what references it to atmospheric pressure. Now moving on to a product overview of the 805 PT. We'll start with the 805 series first. So remember, the 805 is really just an analog transmitter. It's not a digital. Now, if you don't know what the difference between that is, an analog is basically giving you a raw signal output, as opposed to a digital output, which is giving you a more of a smart signal, something that you can communicate with and send signals back and forth. And so the analog output is basically just a 4 to 20 milliamp signal output, or you can select a 1 to 5 volt DC mode output as well. This is for low power options. You have to select the either 4 to 20 milliamp signal or the 1 to 5 volt DC option at the time of ordering. The transmitter itself is a very durable, cost-effective solution. So the 805 PT lists for about $303. That's a really good deal for such a sturdy pressure transmitter. It comes in a solid 316 stainless steel housing. It's a cast housing. It's very durable, thick, and strong. You can drop it on the ground. You can put wrenches on the actual housing and tighten it down, and you won't damage the actual housing. As opposed to some of the other stick transmitters out there that are kind of flimsy and small and can break pretty easily. Very compact design as well. It is about 6 inches tall, so as compared to a Rosemont 3051 or your traditional style pressure transmitter, your space is that it consumes, or the footprint that it consumes, is a lot smaller than your traditional style. We have a question here. It says, do you suggest a desiccant filter on the submersible vent tube to reduce condensation? Yes, we do. So we can offer it's basically a little desiccant tube or filter that is basically in line with the tube itself, and it will prevent any type of moisture from condensing and getting into that tube and causing basically water to get into the housing of the electronics. You can buy that from us. They are disposable, so a lot of times customers that use these types of products, they'll buy those themselves and install them themselves. But we can offer it and provide it and sell it to you as well. The 805 PT is field adjustable. However, it is only field adjustable via our calibration kit, and we'll get a little more into that later. Also, the 805 series carries global agency listings of FM and ATEX. Now moving on to the 805QS. So the 805QS is pretty much everything that I just said, except it includes an additional solid-state switch relay output as well. Some of the specifications, the accuracy on the 805 is a 0.25% accuracy, a 0.25% accuracy of the upper range limit. It has a 5-to-1 turn down. The response time is less than 5 milliseconds, and then it also comes with a 3-year warranty. Like I was talking about with the calibration kit gives the 805 PT the ability to be adjusted in the field. However, a lot of customers view this product as a fixed ranged pressure transmitter. You can specify to us at the time of order what range you need it set at, and we can set that out at the factory free of charge without any additional fees or anything like that. Now, the calibration kit can be purchased as a one-time thing and calibrate any type of 805 PT that you buy in the future. However, you will have to have the software and the hardware to do that. Moving on to the 815 PT and 815 DT. So the 815 PT and DT offer a lot more different options and features in it, all in the same package, whether you ask for it or not. So what it offers is Heart 7 communication protocol, 4 to 20 milliamp output, a Modbus RTU or RS485 serial communications, a 1 to 5 volt low power option, a 9-way configurable switch, and then also it has external magnetic zero and span targets to adjust it externally with magnets. All of that comes inside the 815 PT whether you ask for it or not. So there's no selecting whether you want hard or Modbus or any of that stuff. This is especially valuable to some customers that have equipment out in the field that uses 1 to 5 volt DC, and then some of their equipment uses 4 to 20 milliamp. And it prevents them from having to stock multiple different model numbers when they can order the exact same model number and just set it up how they want it in the field. Pressure ranges that we offer for the 815 PT, we can go all the way from 0 to 5 psi, remember with a 5-to-1 turn down, all the way up to a 30,000 psi pressure transmitter. We can do absolute pressure ranges as well as vacuum pressure ranges if you need us to as well. The 815 DT goes from 0 to 138 inches of water column all the way up to 0 to 500 psi differential. Now moving on to the 815 LT. The 815 LT is basically everything that I just said with the 815 PT. The main difference is there's some different process connection options as well as it's submersible to a depth of 1,200 feet. It has an IP68 rated housing to that depth. Same stainless steel housing. We've added a cage diaphragm seal option to protect it, to have the sensor protected from any type of debris or contaminants and so on. And it also has a 2.5-inch face diaphragm seal that's flush, so that if you're putting it into sludge or wastewater application where you have some sticky substances or debris that could clog a pressure port, this is a great option to prevent that from happening. It can easily be wiped off. This cover plate can be taken off easily by just unscrewing the nuts, and you can wipe that off with a cleaning solution or a rag and then install it back on. This cover plate and this cage is just there to protect it from any type of floating debris, as well as when they're lowering the transmitter into the tank or vessel or whatever it is, it doesn't damage it by when it hits the bottom of the tank or the bottom of a well or whatever it is. Again, it has that vent tube for reference to atmospheric pressure and different options as well. So there's a question that we have. Would that not also allow for a lower level measurement due to a larger diaphragm or smaller span? So no, it wouldn't change the amount of span that you can achieve. Now, you would still be limited by the actual sensor itself. You're correct that a larger diaphragm typically means that you can achieve lower pressures. However, the diaphragm of the actual pressure sensor is the same. We're just adding a diaphragm seal here. Now, if you need a lower range than what our lowest range is, I believe with our turn down, our lowest range that we offer is a 0 to 7 feet of water column. But if you need to go lower than that, that's with a 0.1% accuracy. So if you need to go lower than that, then there's nothing stopping you in the software from going past the 5 to 1 turndown if you need to. And you can always do it in your the software of their PLC or their DCS system as well. Say if their tank is 4 foot or so. And of course you will get less accuracy. However, some people don't necessarily care if it's the difference between an accuracy of a 32nd of an inch to an accuracy of a half of an inch, and that might not be a big difference to them. Here's some of the specs for the 815 PT, DT, and LT. So we've already gone over the pressure ranges, but the accuracy on the 815 series is a 0.1% accuracy, so a very good accuracy. Almost all the times this accuracy will be good enough for what they'll need. There's sometimes when we're competing against a Rosemont or someone like that that has a 0.075% accuracy or a 0.05% accuracy, that the customer requires that, and maybe there's some things that we can do to get there, but if they're requiring that much accuracy, then they probably need to go with that Rosemont or someone else. The response time is less than 70 milliseconds. You'll notice that this is actually larger than the 805 PT, and the reason for that is because we're adding HART communication protocols and a microprocessor and other components that basically the electrical signal has to be filtered through, but it increases the response time for the transmitter. Now, 70 milliseconds is still really good for a HART device. The supply voltage is 10 to 36 volts DC, and then the reverse polarity, EMC protected, same 316 stainless steel housing. Like I was talking about, we have the external magnetic targets. So this is on all the 815 series that you'll see on the casting. You'll see a circle, and then you'll see a triangle in the housing, on the housing. This circle there is, if you place a magnet there for 3 seconds, at whatever pressure is being seen by the pressure port at that time, it will set the 0 to that pressure. And then the same thing for the triangle on the span. So this is useful for a quick calibration of the unit. If you just want to re-zero the transmitter, say you've had the transmitter out in the field for 5 years and the 0 has kind of drifted off a little bit, and say the 0 is supposed to be atmospheric pressure. Well, what you can do is just expose that pressure port to atmospheric pressure and then hold a magnet there for 3 seconds, and it can will rearrange the 0 or reset the 0 to atmospheric pressure. Now, a lot of people talk about, well, what happens if some Joe Schmo goes up there and is holding a magnet, and what's the security risk of that? Well, if that's really a factor and that's really an issue, you can go into the software and turn off those magnetic targets if you need to. Moving on to the switch output. So remember, the 815 series also acts as a pressure switch as well. So there's 9 different ways that you can actually configure the switch in the 815. One of them, the first one is being off. If you don't want to use the switch and you don't need to, you can just turn it off or not use it. The next 2 are what we called our window normally open, window normally closed option. What this does is you'll define 2 set points. You'll define a low set point, and then you'll define a high set point. When the pressure is below the low set point, it's closed. When it's above the low set point, but also below the high set point, it's open. So when it's in that window of the set points, the switch is open, and then it's closed when it's outside of the window. And you can set that either vice versa, whether the switch is open in the window or the switch is closed inside of the window. We also have the next 2 are the single point configuration. So the single point is you define one set point. When the pressure is below that set point, the switch is open. When it's above, it's closed. And then vice versa, you can set it where the switch is closed below the set point and then open above the set point. The next 2 is pulse width modulation. So the way pulse width modulation works is the switch will actually pulse on and off. And so the way you can basically use the switch as a transmitter by utilizing this pulse width modulation method. This is a way that people used to use switches to get a continuous output. So for example, if the pressure is at 50% of the pressure, the switch will modulate or pulse at 50% of the range, or for 50% of the time. If the pressure is at 90% of the range, the switch will pulse on at 90% of the time. And what you can do with this signal is you can send it directly to a pump or a motor or a valve and say, hey, my pressure is at 90%. You need to turn on this pump at 90% of the voltage that it's required to maintain it. And you can say the same for a valve. Open a valve up to 90% open. So there's a lot of things that you can do with pulse width modulation, though it's not necessarily one of the more common ways the switch is used. The most common way that this switch is used for our 800 series or our 815 is the deadband option. So if you're familiar with our mechanical pressure switches, the biggest drawback of a mechanical pressure switch is that you can't really define what the deadband is. For most models, the deadband that you receive is what it is. You can't adjust it. And so there are adjustable deadband models, mechanical pressure switches that have adjustable deadband, but they are limited in what you can do. And also they can be a little wonky as well. And so the adjustable deadband on the 815L or 815 series gives you the ability to set that deadband to whatever you need it to be. It can be as big or large in that range as you want. And so this is particularly useful to save the life of pumps and motors, and if you're controlling something off of the pressure, you often want to control the deadband as well. And so anytime where they're controlling the pressure or controlling something off of the pressure, this is a very useful model. The 815 and the 805 are what we call blind transmitters. They don't have a local indication as a standard. They just have flying leads that will then go to either an HMI screen or a DCS or a PLC somewhere where that signal will go and then be interpreted on a computer or program or a PLC or some other type of method. Now, if local indication at the site of the transmitter or at the site of where the pressure is being taken is required, we can provide a local indicating display. So the option that we provide is a backlit LCD display, has 5 digits, displays units of measurement, and then also it displays the percent of span as well. The housing that it comes in is an explosion-proof FM, ATEX, and CSA-approved explosion-proof housing. It also acts as a junction box as well, having terminal blocks and connections on there as well. It has push-button display as well, so that you can push the buttons to change the output or the assigned values for the 4 milliamp and the 20 milliamp signal. However, note that the display is not, the push buttons on the display will not translate to changing the output of the actual transmitter itself. So the display itself does not actually talk to the transmitter. All it does is it reads it is in loop with the 4 to 20 milliamp signal and assigns a value for a 4 milliamp and assigns a value for a 20 milliamp signal. And then it linearly interpolates in between there. And so if you need to change your pressure reading, you will change the transmitter and then you also change the display as well. The display can be either mounted right on the head of the transmitter or it can be mounted remotely as well. And it can be ordered remotely as well. Also. And so for the 815LT, obviously you can't mount the transmitter on the head itself or on the transmitter itself, so you have to mount it remotely. This is a very low-cost solution for a local indicating display. If you want this option, it is about a $243 list price adder. Now looking at some of the process connections that we offer. So for the 800 series or the 805 and 815 series, we offer a standard A process connection. This process connection gives you a half-inch MPT male as well as a quarter-inch MPT female on the inside, so it's a dual process connection. We also offer the S port, which gives you a flush face diaphragm seal on there, so that if you have an application that has dirty or sticky or high particulate matter in there, this is a way to prevent that pressure port from clogging and getting buildup in there and ultimately altering your signal. We also have the H port. This H port is used and required for any process pressures above 10,000 psi. This is because normal MPT threads won't be able to hold that or seal that pressure effectively. So you have to go to a autoclave fitting for those higher pressures. And then if one of those three options is not suitable, we can also do all sorts of different options on special requests, whether it's threaded and ports, different types of size threads and so on, or direct remote mount diaphragm seals, tri-clamp sanitary fittings, a flange, and then many other options that we can do. For a submersible, we offer the same A process connection as well as the P option, which is a PVC nose cone that is self-flushing. So it protects the cone in there, but it also has a self-flushing port that will prevent any type of clogging from occurring or particulates building up in there. Now, to a certain extent, that will work, but if it's very heavy material, we also have the T option, which gives you a more robust option to prevent against clogging or sludge and slurry applications. This is just a good tool to kind of break down the differences between all the different series that we offer. Now getting into some applications. Oil and gas is littered with different applications for the 800 series. I won't all through the upstream and midstream, but I won't go through all of these. I'll get into more of these application notes instead. So wellhead control panels are a big application where we sell a lot of pressure transmitters. As you can see here, there's a lot of different transmitters being able to be put into a very small area. For example, if you were to use a Rosemont 3051 with local indication and the traditional style housing, this box or container would have to be much, much larger to accommodate all those different pressure transmitters at that size. Monitoring casing and tubing pressure. This is a very common application for this product as well. This specific application is a customer that before the 800 series came out gave us feedback that WICA was, their operators were using WICA, and when they put the wrenches onto the housing, they would actually turn it and they wouldn't put it on the actual wrench flats, and they would actually destroy the housing in doing so because the WICA units were fragile and frail and couldn't handle that type of torque. That's why we went to such a durable stainless steel cast housing design to prevent anything from that from happening where the operators don't install it correctly. Residential gas is another common application, monitoring the pressure on gas lines going to residential facilities. If there's a drop in pressure, that can mean there's a leak in a gas line. Wellhead pump control and shutdown. So the 805QS can actually be used as an interlocking system so that if the pressure gets too high or too low, you can use the switch feature to shut down the well and force the operators to go out there and check the transmitter and check the situation. And the only way to reset it is to go into the transmitter itself and reset it manually. That way it forces the operators to go out there and check and make sure that they solve the solution or solve the problem before they turn everything back on. Well site remote monitoring. So there's a lot of well applications out there that are remotely located and don't have ease of access of power. And so those products will often require solar power to operate it or a battery, and where the power is actually quite limited. So what they'll have to do is use our transmitter in a 1 to 5 volt DC mode output. This fixes the current and to a very low power requirement to be able to utilize the solar power most effectively. High pressure monitoring on sand recovery for fracking operations. So this is another remote application where they're running off of a solar panel and they need to use as little power as possible. This is a rupture disk application for a chemical plant for refining. So they need to monitor the pressure coming off of a rupture disk. And what a rupture disk is literally a disk that is designed to burst at a predefined pressure. And so what when this disk bursts, there's really no way to tell unless you have a pressure switch or a pressure transmitter there. So what they were using was our pressure transmitter in line with it to monitor that rupture disk, and the switch would alert them or turn off something, while the transmitter was able to give them a continuous output to possibly prevent to alert the operators to possibly prevent the rupture disk from rupturing to begin with. This is a boiler feed water application. This is an application where they needed a diaphragm seal or a gauge, as well as a transmitter output going back to their DCS system, and all on one pressure port. So they only had one pressure port, but they wanted local indication via a separate technology than the actual gauge. So they wanted two technologies all at the same pressure port, and so they have a diaphragm seal here, and then teeing off of the gauge, you have the transmitter on there as well. This is for high and low pressure auxiliary steam systems. This was a power plant in China that was previously using a Rosemont transmitter. And so this was an application where they didn't need to spend such high dollars on the Rosemont, and they could use ours with a much smaller form factor as well. The 815DT has a lot of different applications for it. One of the common applications is monitoring the life of filter systems. So when you measure the differential pressure across the filter, there's a drop in pressure. And the higher the drop in pressure, the more clogged up that filter is essentially. And when you have a differential pressure transmitter on there, you can monitor the life of that filter, and you can know when it's time to replace that filter. Distillation columns, remote applications, compressor skids, but also the A15DT can be used to monitor or measure level by taking the pressure at the bottom of the tank and taking the pressure at the top. This gives you the ability to give a level output of a tank that is sealed. Remember, the submersible level transmitter is used for vented tanks that are exposed to atmospheric pressure, whereas the differential pressure transmitter is used for tanks that are sealed, so that because you need reference to that top atmosphere or that top pressure of the tank. And also you can measure flow with the A15DT across of an orifice plate. This is an application where you're on a chemical injection skid where you're measuring the level of this tank storing the chemicals via a differential pressure. You can see the differential pressure transmitter here. Um, lift station level, so now moving on to 815LT applications. So submersible pressure transmitter applications. One of the big ones is lift stations for water wastewater treatment facilities. So sewage systems and sewer lines from houses and businesses and residential areas all have to be pumped to a water wastewater treatment facility. And they'll have what is called lift stations. These are basically booster stations to if the origin of the waste is at a far away from the water wastewater treatment facility, then you need these little booster stations or lift stations to push it along to the station. And you could have multiple lines coming all into this, feeding into this one lift station, where then it's pumped again and boosted out to maybe another lift station or the actual water treatment facility itself. And you can see the transmitter in here to monitor the level. This can either monitor or control it, but you also have possibly float switches in there as well to provide high level kill or to open or pump to control the pump as well. Leachate control and collection. So at any landfill out there, and landfills are anywhere where there's humans, there's landfills. Leachate control and collection is required. And so leachate is what is produced at a landfill, and it's basically a combination of decomposing trash as well as rainwater to create leachate. It's just a kind of real dirty water combination and composite. And so that leachate cannot be just dumped back into the ground. So you have to collect it and you have to properly treat it before it can be sent back into the ground, because it can damage the environment and the local drinking water of where it's disposed of. So you have to collect it inside the leachate collection system, and you'll have a transmitter there to monitor that level as well as where it's being collected and stored as well before it's sent to a water treatment facility. Another application is sensing water level in a municipal well. So a lot of small towns and residential areas and many cities get their water from wells. And the main way that is monitor the level of that well is by dropping a submersible level transmitter down into that well. How they'll do it is they'll have a PVC pipe that goes down in there that kind of guides it down into the well, and they'll have the submersible transmitter there as well. This is important to monitor the level of that well, because if the level starts to get too low, the city or the town can start conservation methods to prevent that well from going down too much, or it can alert them to make sure that they don't operate that pump without any liquid there, because if you run the pump without and it's just air going through that pump, that can severely damage that pump and you'll probably have to replace it. Another application is for sensing storm and water levels. So in the sewer systems and where the rainwater is collected of heavy storms, you have to monitor the level to operate pumps to properly pump that water out of the sewer system into somewhere else so it doesn't flood cities or residential areas and so on. Moving on to out of order, we only got a couple more slides. I know I'm running over my 30-minute time limit, but almost done here. The 800 series offers a quick ship program. We guarantee a delivery of less than 48 hours for quantities of less than 3 for certain for the 805 PT, the 815 PT, and the 815 DT. We're working on adding the 815LT to that list as well. This is very useful for plant operators that are in urgent situations where they need a transmitter immediately. And we say less than 48 hours, but oftentimes if you give us the order at a certain time, we can possibly ship during the same day. But that is all that I have Thank you everyone for joining. We really appreciate it. If you have any feedback for how to make these webinars better or different topics that you'd like to have, please let us know. But I'm going to stick around for any questions that you guys have had during the presentation. I'm going to stick around for maybe another 5-10 minutes to answer any of those, and feel free to type those into the chat and ask them. But thanks again everyone for joining, and I hope you have a good day.